saddles will basically show you like the water separation line. Any rainwater that falls within this purple line will basically be drained by this major stream here, the third eastern stream. Any water that falls on the other side will basically be drained through some neighboring stream. So the bigger this drainage area, obviously, the more probability that you will get water in the stream. If a stream is responsible for draining 2 square kilometers, there might be less probability of water compared to a stream which drains maybe 30 square kilometer of mountain range. So that's also one thing you can keep in mind. I know it's a little more technically, but this is all about survival. And I mean, sometimes you go trekking in a place in a valley where many people who have gone with me, if you don't have water, like say for 10 hours, 12 hours, it becomes very mentally difficult, and it's difficult to get a group of 20 people still moving forward. So that drinkable water, that dependency is there, so it's very important to plan for places where you can count on refilling your water during a trek. Next one. So mostly I'm using Google Maps, which has the terrain maps. Standard view will be your route maps or satellite views. Within Google Maps on this, you can select terrain maps, which give you access to the contour maps. Next one. Let's talk a little about the different sources of maps that we have for India. Within every source of map, I've also indicated the scale. So a smaller number here basically gives you a higher resolution or a more precise map, so a more detailed map, which will be especially useful for trekking. While trekking through a mountain range, you're not going to cover too much. I mean, some places where it's high density of vegetation, or where the terrain is very tough, or where you're walking steep up, or it's like very sunny outside, or you're carrying a lot of luggage, right, on a 4-5. Sometimes we go for 9-day treks, you're carrying 9 times 3 meals with you, so you're carrying like a large amount of food with you, weight with you. So you're not going to cover too much distance. It's not like on Marina Beach where you can easily jog for 3 minutes and cover like a lot of distance. In a day we might only cover 10 kilometers, but it might still have been a very intensive physical activity. So Google Maps I've shown you. Google Maps will actually have use the same data source as the second one, as RTM. We'll talk about that later in a minute. Survey of India has beautiful maps. Only problem is they are not available in soft copy. I believe somebody told me recently that they have started digitizing their map, the government, and started uploading them. But they are very expensive. I believe they are asking around 5,000 rupees for like a topographic map created by the Survey of India, which just covers like say 9 by 9 kilometers, so 9 by 9 minutes, which means miles. So paper maps are much cheaper. I mean, Survey of India sells paper maps. Any map from any place in Tamil Nadu you can get in Chennai. The survey is in Guindy. Any map in Karnataka, you go to Bangalore. So you typically go to the capital where you can go to the survey and obtain beautiful detailed maps. They're not only containing contour lines, but they will contain a lot of other detail also, as we'll see in a minute. There are 2 other sources, the American maps, the Russian topo maps, which will contain a lot of useful detail in addition to contour maps. But if you look at the scale is much worse. It's like a much rougher map. 1 by 200,000 means that 1 centimeter on your map corresponds to 2 kilometers in the fields. Okay, so that means that if you want to really walk for 2 kilometers, which can be almost 5-6 hours of work on a trek, that you only have covered 1 centimeter on your map. So you can imagine that that is not very useful for a trekker. So let's just take a look at every type of map on the next few slides. So Google Maps, we have covered all the pictures I have seen in the previous slides. These are Google terrain maps. These are my main source because they are very, user-friendly. They are easily accessible. The entire world, India is all covered at a very high precision. You can draw your rail lines on top of that. You can indicate peaks, you can indicate valleys, you can indicate all kinds of reference points. You can easily download those reference points from the Google Maps into your GPS and then go to the mountain range and have those reference points with you. So it's very convenient. One other source which I recently discovered with the help of one of our members is this SRTM. So I found on Wikipedia some background on this. So it seems like around 12 years ago, the NASA has actually made a digital elevation map of nearly the entire world. They haven't covered the polar areas. I think they have gone to around 60 degrees north and 60 degrees south. But they have done an amazing job in terms of creating topographic maps with a precision of 1 second in the US and 3 seconds in the rest of the world. 1 second, as we'll see in a minute, corresponds to around 30 meters roughly. So 3 seconds means that we have a resolution of 90 meters on these maps. It basically means that every pixel on your screen corresponds to 90 meters, which is still quite a bit, but it's quite useful. So let's go to the next one. The nice thing with these SRTM data is that it's freely available. I can give you, you can find all the details in the links that I've given here. We can have a more elaborate workshop. But you can basically download data from any part in the world, including India, topographic data with a 90-meter precision, and with some tools like this ground truth tool, which is again freely available tool, you can basically extract again the same contour lines from this. These contour lines will be stored in a vector format, which you can even use in very cheap, very low-end portable GPS navigators. This is like an E-Trex from Garmin. I think this is around $120 US if you buy it in the US. So for 5,000 rupees, you can have a GPS. None of the GPSs you will buy will have any decent maps for India in them. They will typically come with good maps only for Europe or the US. So you will have to, go through some of these tools to download data from SRTM. You'll have to do a little bit of command line conversion, and basically you'll be in a position to download beautiful topographic maps. We have used this unit and this map on our last Polamaa trek during the 4th birthday, which was very useful. I was really stunned to see this, because until then we had actually been using a more expensive Garmin GPS Map 62 model, which is almost 15,000 rupees and quite expensive. So next one. These are the Survey of India maps. So as you can, maybe we can skip to the next slide. So as you can see, in addition to contour lines or topographic lines, which show the elevation, the ups and the downs in the terrain, the valleys, the peaks, we have a lot of other detail in these maps. If you go back to the previous slides, which shows the legend, you can see like mainstream, side streams. You will see tar roads, highways, sand trails, jeep tracks, walkable trails, villages, temples, ponds. Anything which was basically, of some kind of useful purpose has been documented on these maps, which, according to me, were created by hand. One more nice thing is that the scale of the maps are like 1 by 50,000, 1 by 20,000, sometimes 1 by 10,000. So this is very nice, because 1 by 10,000 means 1 centimeter on your map corresponds to just 100 meters in the field, which is awesome. So very high detail on these maps. I'll skip to the next one. So here you can see, if you go a little back, this is where they went for the 4th birthday trek, Koli Hills. So this is the valley along which they have trekked. Here somewhere you'll have the Koli Falls, 15 meters, and next to that you'll have that famous temple in Koli. So you can see a lot of villages there. All these things are villages. You can see major streams. You can see walkable trails used by villagers. These maps are, giving you all the details. They give you the main streams, they give you the side streams. So lots of rich detail is there, which you can use on your trek. Only problem with Survey of India is these will be like those big A2 sized or A1 sized sheets, so paper sheets. So it's not always easy, right, once you're in the field to kind of know where exactly you are in the map. So to do that, I'll talk later a little bit about georeferencing, how you can basically digitize these maps by yourself and kind of scale them, so you can download them in your GPS unit and kind of know exactly your current location on the map. Next one. So one map, which is not that useful. If you look at the scale, 1 by 250,000, it's like huge. 1 centimeter is 2.5 kilometers on the map. So not useful for trekking, more like useful for biking or touring with the car. But one very nice thing with the US Army maps, if you go to the next slide, you will see a sample. Okay. Here you can see, this is the website where you can download like maps from any place in India. The Americans have mapped the whole of India, I think Pakistan, Bangladesh, and every square, I think, is around, say, a certain size. I don't remember exactly how much. You can click on any rectangle, and then in the next slide, you will get like a detailed topographic map for that region. So these are freely available. They are in software formats. and they are like georeference. Georeference means that we know exactly the location of this map. So the nice thing with these maps is that they contain, again, a lot of interesting detail. So here you see the Tirupati Reserved Forest. This is basically the Venkateswara National Reserved Forest. On this American map service map, you find a lot of interesting detail. You can find like old jeep tracks which go to the hills, which were, I believe, built by the British almost nearly a century ago. You'll find old rest houses which are now in ruins because they are like very old in these places here. Thanks to some of these maps, if you go to the next slide, we have been able to kind of locate some of these century-old buildings which has been put by Britishers or other ancient civilizations. Obviously, after so many monsoons, so many seasons, and with no maintenance, they have been fully overtaken by the jungle. But it's really exhilarating to kind of take position data from these American, Russian army maps, load them in your GPS, trek for almost 2 days in no man's land in the jungle, and try to kind of locate and uncover these old remains of human civilization. Next one. So just whatever the Americans do, I guess the Russians have to do. So Russians also have put up detailed topographic maps of India. Next one, we can look at a sample. Nice thing with the Russian maps is that the scale is a little better. It's 1 by 200,000, so it's a little bit more detailed. And it's GIF format, it's not JPEG. So, I mean, the quality of the map is better. I mean, the quality of the image is quite good. Here again, you see that same, for example, the line you can see there, that double line, is the Jeep trail. You know, like hundreds of kilometers of old Jeep trails, century-old Jeep trails, which runs through the Venkateswara National Reserve Forest, just to give you one example. Next one. So here again, like using this map, there was some old forts. If you look at the top corner here, somewhere near the famous Tada waterfalls, here you have Tada waterfalls. Sorry, here in this small valley of the Tada waterfalls. On the eastern ridge of the Tada waterfalls, this dot, you have a fort, some old fort which was built, not sure who has built it there. But thanks again to this old Russian map, which is sometimes like almost 80 years old, we were able to kind of locate these old forts which was built so many years ago. Next one. Then, like I've talked about the SRTM data, which was made 12 years ago. On a more recent mission, NASA has created like a more detailed model. It's called the SRTM maps. You can read the full form here. It's like a newer technique they have used to kind of create digital elevation maps. So these maps are also available for free download. We are still studying this, how to actually extract this data and convert them to useful topographic maps. Nice thing with this map is that it's like very high resolution. It's just 30 meters. So every pixel on your map corresponds to 30 meters, which is 3 times the resolution that you currently have available in Google Maps. So in addition to contour maps, we also sometimes use this Wikimapia. So Wikimapia is very useful to find a lot of like villages, small villages, which are not documented on Google Maps, near the base of the hills. This is like probably the Nagari range. So all these red dots correspond to small villages, which basically kind of allow you to find some small roads, jeep trails, to get as close possible to the stream which exits the hill, so you can kind of drop the people close to the hill and start trekking. So Wikimapia is very useful because many people contribute to this. It has much more reference points than the normal Google Maps. Next one. OpenStreetMaps is also very useful. Here again, people can upload their trails. So here again, you will find some smaller routes. I mean, national highways, state highways, it's all available in Google. But if you really want to go close to Nagala, close to Nagari, close to other mountain ranges, close to the base of the hills, it's sometimes very difficult to find the roads. These maps can help you a lot in kind of finding access roads to your starting points of your treks. Next one. Let's spend a few minutes. Can we do a time check? How many minutes have I been? 7:55. Okay, let me just do a couple more, give a little bit more info on GPS. So GPS stands for Global Positioning System. 6:45, yeah. So I think I will spend another 10 minutes on this. So GPS is basically, if you go to the next slide, so in the last couple of decades, the Americans, the defense organization has launched different generations. These are all like the types of satellites they have launched, the number of successful launches, failures, etc. So within since like, 30 years ago almost, they have launched several batches of satellites. Out of these batches, there are like 3 batches, 7 of the latest generation, 12 of the previous, 11 of one more previous generation. So total of 30 satellites are spinning around the globe. And the purpose of these satellites is basically to accurately identify your position. So we have these GPS systems in your mobile phones. We have the GPSs now, which are more common in cars. We use the portable GPS navigators on our tracks. So these are basically receivers of the signal which is transmitted by these satellites. Using like a minimum, so typically if you go back to the previous slide, so you can see the satellites are moving. They are not geostationary, I believe. They are moving at a higher speed around the globe. So if you're somewhere here on planet Earth in this blue dot, planet Earth is moving, the satellites are moving. So the number of satellites that will be kind of visible to you will be changing. So you can see the number varying here. So typically, if no obstacles around you are blocking, you're not in a deep valley or there is no dense vegetation around you. So you should always have around 6 to maximum 12 satellites to which you have a clear point of view. You need a clear point of view in order to have a proper reception from the satellite. So with a minimum of 3 satellites, and of course the more satellites you can see, you're receiving the signal from, the more precise you will be able to identify your position. So with minimum 3 satellites, if you go to the next slide, you will be able to what they call triangulate. And there are some mathematics behind this, which I think we don't have to go in detail now. But with the help of minimum 3 satellites, you can kind of accurately find your position on the Earth. With the 4th satellite, you can also identify your altitude or your elevation above the sea level. So this again very useful because it gives you like a unique position of yourself, which is okay. Okay, who cares? Latitude, longitude, I'm at this position. You care because using that position, you will be able to find exactly where you are on your map. You're typically carrying a map with you, which is a reference for you to know where to go next. So with that position, you will be able to know exactly where you are on the map. Next one. So let's talk a little bit, 2 slides. This is a bit more technical, but I think it's important for you to have a basic awareness of this. So your position on the planet, here you have a picture from Google Earth, is determined by 2 coordinates, the latitude and the longitude. So the longitude is basically your, you have longitude east, you have longitude west. Somewhere, when the British, I think this system is a British system, when they came up with it, somewhere here in Europe, you have London. Through London, you have drawn a line from the North Pole through London, and where it hits the equator, that's basically your reference position. That's basically your 0-degree position. If you go to the right, you're going towards the east. If you go towards, say, the US, towards the left, you're going to the west. So every position to the right, to the east of London, if you start from that reference position, that will be east. So here you can see 50 degrees east, 60, 70. Chennai will be around 79 degrees east from London. So this gives you like your horizontal position, you could say, right? With London as a reference point, you're either so many degrees to the east, so many degrees to the left. So you have all of you know the basics of a circle. You have 360 degrees around the circle. So these 360 degrees have been split up in 180 degrees east, 180 degrees west. So in India, obviously, will always be, 1 degree is, of course, a long distance. The entire perimeter of the planet Earth is around 40,000 kilometers. So if you divide that by 360 degrees, that means that every degree is like a significant distance. We'll do a bit of a more exact calculation in a second. So similar to your horizontal position, if you start going away from the equator, either to the North Pole or to the South Pole, that is going to determine your latitude. So for every, from the equator to the North Pole, that will be 90 degrees. From the North Pole to the, from the equator to the South Pole, That's 90 degrees to the south. So again, if you look at Chennai here, so here you have 10 degrees north, 20 degrees north, 30 degrees north. So Chennai is around roughly 12 to 13 degrees north, which means north above the equator. So with that 69 degrees east, 12 degrees north, you have an exact longitude, latitude, so you have an exact fix of your location. So in this case, Chennai. If we zoom in a little on the next slide, so if you zoom in, of course, 1 degree is a very rough measurement, right? So because the entire Earth, planet Earth, is 40,000 kilometers around the equator, roughly. It's a British system, so we cannot really work in kilometers. So 1 mile, I mean, you have 2 miles, right? You have the land mile and the nautical mile. The British have worked with the nautical mile to determine this latitude, longitude system. So a nautical mile equals 1,000, a sea mile equals 1.852 kilometers. So 40,000 kilometers, the circle around the Earth corresponds to 21,598 miles. If I divide 40 by 1.8, I come to this. This corresponds to 360 degrees. I feel like some mathematics teacher here now. Sorry for that on Sunday evening. So 1 degree corresponds to 60 miles. So again, 1 degree they have cut into 60 pieces, 60 minutes. So 1 minute basically corresponds to the land mile. That is basically how the Britishers have defined a land mile. A land mile is basically 1 minute, 1/60th of a second, having 360 degrees over the entire planet Earth. So 1 minute is again cut into 60 pieces. So if we divide 1 mile, 1,852 meters by 60, then we can figure out that 1 second of latitude, 1 second of longitude corresponds roughly to around 30 meters. So if you walk on your map, for a second you walk for 30 meters. If you walk on the map you will never see meters or kilometers, you will see seconds and minutes. If you walk for a minute, you have walked around 1,852 meters. So this is basically to give you a basic idea of conversion between our units of meters, kilometers, miles, and the minutes, seconds, degrees, which will be used very frequently on the maps. Next one. So here again, if you zoom in a little, right, so on Google Earth you can put up a grid which shows you like latitude, longitude. I think we can go to the previous slide, Anand. So here we have a fragment of IIT Guindy, the campus. Here you can see the swimming pool. Here you can see the round circle in IIT Madras. So here I've zoomed into a level where the distance of the grid, the distance between this line and this line is around 13 seconds. So here you can see 13 minutes, 59 seconds. Here you can see 14 minutes, 25 seconds. So the difference between two lines is 26 seconds. So that means this is around 13 seconds. 13 seconds multiplied by 30 results, right? So this gives you an idea. This grid is around 400 by 400 meters. So that's how you calculate your distance on your maps. Next one. Let's skip to the next one. So here you can see a typical handheld unit we use. Many people are asking me, can we use our mobile phone with GPS receiver in the field? It's not going to be much useful because your battery is going to drain very quickly. Within 2 hours, switching the GPS on, the battery will go. Mobile phone is not weatherproof, it's not waterproof. And it's typically not that open. I mean, it's not going to be that easy to download maps or record trails. Of course, now it has become a bit easier with iPhone and Android. But these units are much more useful. They are rugged, they are waterproof, they are weatherproof, they are shockproof. They also work on AA batteries, so you can use this for a 9-day trek, carrying enough batteries with you. You don't have to recharge it. Many times we have been using these units of Garmin. We use Garmin because I think Garmin is one of the more rigid, rugged types of handheld units. And if you go to like the next couple of screens, I think I'm going to stop with these because we're going to get a bit late. Let me show you like 3-4 typical screens which you're going to see on these GPS units that we carry on treks. One screen is basically which is useful when you switch on the unit. When you switch on your receiver, your satellite receiver, it's not going to determine your position immediately. It will need around 2 minutes after a cold boot, after a cold start, to kind of slowly start connecting with the different satellites. So it will show you which are all the satellites, say, like here is north, west, southeast. Where are all the satellites that it's able to pick up a signal from? It will show you the strength of the signal to every satellite. Some satellites you might have a clear view, you might have a very good signal coming. Some satellites might be just below the horizon or might be behind some dense forest that the signal that comes to your receiver is much weaker. So again, minimum 3, any more number of satellites will add to the precision of your receiver. On a civilian receiver, military receivers will have a higher precision. On a civilian GPS receiver, you will typically have a precision of around 3 meters, corresponding to 15 feet, which is more than sufficient for a trek. Next one. So here you can typically see the main screen that we'll be using. So again, I'm telling you, whenever you buy a GPS, most of you get them from the US. They are much cheaper here. Locally in India, whatever you have available, it's going to cost you much more, I guess, due to import duties. Whenever you buy a GPS, it's going to be totally useless. Whatever you're going to see when you switch it on will be a blank screen. There will be no map inside. Nobody will be giving GPSs with decent topographic maps of India. That's why it's so very important in the first few slides, that I've explained, that you really need to download and kind of process these own maps, put your own reference points at peaks, valleys, ridges, so that you have sufficient reference points to take along with you. Otherwise, you're just navigating blindly and you're just going to follow maybe the sun or the wind or whatever. It's not going to be very, predictable, your trail. So, right, this is your map screen. So typically, it's nice. The GPS shows your position on the map. It not only shows your position here, it shows a triangle. Triangle is actually going to show you the movement of direction. So it's also clearly show you along which line you're progressing on the map, which is very interesting because typically it shows you like whether you're going towards your point of destination or not. Next one. So working with GPSs, I think we don't have time for this now. We need a full-fledged workshop of 3-4 hours to explain this. Data can be extracted from GPS's reference points that you track, that you indicate whenever you find drinkable water, whenever you reach a peak, when you find some old jeep trail, when you find some old ruins, you can put a reference point at that latitude, longitude. Those reference points, those trails that you mark in the field, can be extracted from the GPS using the standard GPX format. It's a textual format that will give you the exact latitude and longitude of the, whatever point you have marked when you took the GPS in the field. In addition to the latitude and the longitude, remember what I said, if you have like a clear